All right, and welcome over to our next module. We're going to be going over Linux Privilege Escalation. We're going to be using the Try Hack Me room for Linux Privilege made by the amazing hacker Tibris. We're going to do an overview of what each one are, and then we're going to do the actual examples, one from each section. So, what are we going to be covering? We're going to be doing service exploits, weak file permissions. We're working with sudo, cron jobs, suid, and sgid executables. Looking at passwords and keys, NFS, as well as kernel exploits. Now, when it comes to exploits, I do like to ask myself a certain list of questions, like what type of system is this, and what type of exploits can I find for this, and what types? Do they going over for particular services or actual kernel? And I like to see, like, what does the code do? So how does the code work? How do we compile it? What's the user commands that we give it? And then is this regular just execution, or is it doing privilege escalation? What is it exactly that we're doing all together? These are some basic things I like to ask myself when I'm looking at these things. Next, so we're going to be looking at weak file permissions. If there's a readable Etsy shadow file, if we can read it, we can copy the contents of a hash from one of the discovered users, primarily root or whichever main users on the system, and then copy that over to our system, saving it as a hash.txt file, then running the John with the Queen's amazing hit Rock You to txt file in order to crack that hash. And what about writable Etsy shadow files? We can use commands such as make password to create a new password hash and then edit the shadow file and replace it with the ones that we created. What about writable Etsy password? We can use OpenSSL to generate a new password hash and then add that into the actual Etsy password file. We have some shell escape sequences where if we do have an actual user account, and this is the only way that it works, if we have a user that has a password, we can run sudo-l to get a list of all the available binaries that we can run as sudo. And once we see that list there, we can look at sites such as get the fuck out of here, beans, to find escapes that we can take advantage of. Now, environment variables. These are a little bit interesting. Again, we'll need an actual user account in order to get this set up, because we will need to actually take advantage of a user's environment variables. We're going to look for things such as environment underscore keep. This so that we can actually make changes to it. We can create a shared object with GCC, and we'll use it to create and compile a shared library between the user and root that will always load first before anything else, linking us to the user's environment variable. This way, the user will always be root when logging in. Think of the kamikaze bomber Nicolas Cage film Face Off, where in order to stop them, he must become him. This is the next one here. We're going to deal with the file permissions. How do we normally deal with that? We have to look at what cron jobs are running. And we view the current cron jobs by catting Etsy cron tab. And this will show us things like world writable file permissions on suspect files. If we can make changes to them, if this is from a job, then we can replace the file contents with something like a reverse shellcode. Then save that, and then when the cron job officially runs, we can get a reverse shell on our system when we set up a netcat listener. And path environment variables for cron jobs, we can note a certain section in the results of the cron tab where it says shell. We can add commands to make a file to create a root shell when the cron job runs, and we call it with the -p. So if we have temp/root bash, for example, and we place this as a command, then all we have to do in order to run it is simply call that path, temp/root bash, and then -p, and we were able to get a root shell this way. Wildcards. These are a little bit interesting because these are pretty helpful on their own. What we see here is the command is being ran with a wildcard, so everything that's in that particular folder will all get compressed into one like file. So there may be a cron job to run a backup, where we see the tar back up and then have where it would go. And let's see what we can do with that. What we can do is we can use MSF Venom to create a reverse shell with a ELF extension. ELF is basically the Linux version of a Windows executable file. We can create a checkpoint on a folder used for the cron job, so the path where the cron job is running. What is this going to do? It's going to create a stopping point to tell tar, hey, before you do anything to this file, see what it does first. So if we have a command in order to execute maybe a root shell or something like that, and we place that code into that file, what happens is that once tar starts to run, it'll look at whatever files that are in a current folder. Then once it gets to ours, it goes, hold up, wait, I need to see what this does. It'll execute it as root and allow us to be able to get a shell on our system once we set it up with a netcat listener. It's pretty interesting one for that. Now, SUID executables. And we have a nice little snazzy command here where we will search for the entire system to look for anything that has the SUID bit set on it. So if there's anything that we find that's out of place, we can try to use that in order to escalate our current privileges. Now, what about shared object injection? So say we find a file where we don't know the end result that it's running, like it's like a progress bar that just runs and that's it. We can use commands like strace to look for issues from the file that we're trying to run. Then we can use the command to redirect the standard error to standard out to see exactly where the error came from. So what that'll basically do is once the application runs, it'll show you every command that it ran and then where we would find the error at. So now with this new information, we can pipe it with grep with the _I capital E to ignore the case and look for patterns that are extended regular expressions that we're looking for. So we'll have it look for these specific type of words, and then we could find what's missing, replace it, and then use that to compile, to put together like a bash shell to run, and get escalated privileges that way. Sorry, let me take a sip of my water. Getting a little bit dry. Refreshing. Next up, environment variables. And if we find an environment variables where a command is not being called by the full path, we can just compile a replacement that is designed to spawn a root shell. Once it's compiled, assign the path of the missing command to where our file is in that variable, so whenever it's called, it calls our code. Now, abusing shell features. This one, I'm not sure if current systems are running this, but this is only a vulnerability that only affects Bash version 4.2. So what it means is we can define shell functions with names that resemble file paths and then export those functions so then that they're used instead of any actual executable in that path, though, meaning that we can reassign what an executable's function is other than what it's used for. And other thing, and the reason why I mentioned that I'm not sure if it's still an issue, is because there obviously have been multiple updates and upgrades for systems, so doubt that that particular exploit would work currently. There is, however, another one where we can reassign a variable in an environment application to make a copy of a bash shell, and we can use that to escalate our privileges that way. Now, these are pretty straightforward. Normally when we do have a shell in our system, the first thing that we do want to run is normal post-exploitation commands like uname, hostname ID, and things of that nature. But one other thing, other than ls-la, is going to be the history command. And as just in case, just run the history command, and it'll show you all the commands that had occurred prior to our getting our shells. So whatever, if there was a user who recently logged into an application, tried to use SSH or FTP or something like that, and they had to enter in those commands, we can see those from the history and be able to use those to our advantage if we can. Config files, the same thing. Those are going to be in maybe like folders that we can't see. This is also where ls-la comes into play, because it'll show everything including hidden folders and files. So we can find something that may have, if we if we do a regular directory listing, we see desktop, like downloads, documents, things of that nature. If we unhide everything with the LA, then we can see things like .ssh, .config, and things like that, and we can see if what's in those folders there. And SSH keys falls under this territory. If we do have access to be able to see this folder, we can do a couple things. Like if we see a actual key there, we can copy the contents onto our system and paste that into a new file. And once we give it the correct permissions, we can use SSH to connect to a system with only that key file, so we won't need a password at all. So by simply using SSH-I, that's specifying that we're going to be using a root key to identify ourselves, the actual username we're connecting as, and the IP address. Network file shares. Now this one's a pretty interesting one to look at. So we can create, if we are root on our system, we can create a folder, a network file share, that says if you want to come and connect to this system here, here's a file path. We can make our mount point on our system and place like a payload in there, and then call that file share from the target machine, which will connect to us, and we can get a root shell that way. Kernel exploits are sometimes a last-ditch option if we exhaust all of our resources. I like to place this as the second thing I look at to keep it in my booty pocket as a just in case. So if I'm working on one exploit, I want to look for a kernel exploit right next to it. So if I find anything else, or if I'm stuck, I have that kernel exploit right there to just say, screw it, I'm going to use that. All right, so now that that is done, let's get to our examples. All right, let's start with our first example for weak file permissions with a readable Etsy shadow file. All right, so the first thing that we're going to want to do is we're going to want to cat those right there, Etsy shadow, and we see that we have their hash right here. So let's take this entire line, go ahead and copy that, and then create a hash file here that has this there. And we're going to use John the Ripper, oops, forgot to save that, in order to crack this. So we're going to enter John, and then our word list. Okay, I don't even know if this is autocomplete or what, but what the hell are you doing? All right. Go over to where our Rocky word list is. Okay, I'm using the John, specifying our word list right here, and the file that we're going to be cracking, which is going to be hash2. Going to go ahead and hit enter there with the H. No password hash is loaded. What you talking about, punk? Hang on one second. Let's fix this up. Whoop, that's a little bit too high there, buddy. Let's copy that. Okay. Let's go ahead and clear all of this out. Actually, you know what? No. Let's just do it like that instead. Okay. Save that there. Run John again. There we go. So took the hashes from that from the Etsy shadow, and then ran that against John, and we were able to crack the password here, which says for the root account, the root password is 123, and the regular user is 321. All right. Next up, let's do shell escapes here. Let's go ahead and clear this out. I said clear this out. What is this doing? Are you giving me trouble? No, you're not. Okay. Okay, what is the screen doing? We're closing it out then. Fine. Now we have to reconnect with SSH. Oh boy. password 321. All right, cool. So let us now with shell escapes. This is where we're going to be taking advantage of sudo-l. We have a user account, which is the only way that we can actually use this. We use sudo-l. These are all of the executables, all the binaries that user can execute here. Now, what's our next step? We go over to get the fork out of here, bins, and work down the list and see what works. So, what's the first one that we got? We have if top. What is this? We have a shell. Okay. Let's see what this is. All right. Execute this one here. All right. And that one works. So we are now root. Let's go ahead and switch back over to user. Clear the screen out. Crap, I shouldn't have done that. Sudo-l. All right. How about some others? There's some that might be self-explanatory for they might not even like exist. Like find. I don't think there would be one for that. I don't believe. Oh yes, there is. Okay, so there is one with shell. Alrighty. See here, we can get a root shell to break out of the restricted environment by using the find command. Okay. Let's see what that one does. All right. And the same thing. So as we see here, this is a great resource in order to find different types of different types of executables that we can take advantage of in order to escalate our privileges. Again, this only works if we have an actual user. If we are like a regular user, we can attempt to some other like programs in order to escalate our privileges, but this is the primary way to get like more of an accurate list of what all that we can actually do. So let's check out our cron jobs here. Now let's go ahead and clear this out. And let's look at what cron jobs are running by going to cron tab. Etsy, not estimated time of arrival, you numbnut. And we see that we have two programs here that are running under root. We have an overwrite that is being ran by root, and we have a compress that is being ran by root. So if we want to take a peek at this one here, go ahead and find it first. Okay, and we located it here. Let's see what it has in it. Cat, not Gary Newman's cars. Sorry, an 80s pop culture reference there. Overwrite.sh. What do? You echo the date and you append it to path temp to a file called useless. Yeah, you really are. So what can we do with this here? We can take advantage of this by changing the code in here to run something else like a reverse shell. So let us go to payload all the things. And look for a reverse shell that we can use here. So what do we have here? Scroll down. Here we go. Reverse shell cheat sheet. All right. Let's go ahead and use a bash reverse shell here to give this a shot. Open up our nice little text editor. Get our IP address here. Go ahead and copy that. Copy that there. Change this. And let's start up our netcat listener and see NLVP 4242. Now let's use Pico against this to edit this file. Oops. Crap in a hat. There we go. Okay. Oops. Go ahead and copy this. Get rid of all of this. All of it. All right. And now we patiently wait. So now we just wait for this to run the cron job, which it looks like it's running something. Either that or it is very slow. So is this file like smooth jazz? Just going all slow, soft, and easy here? Come on, little buddy. I think you can. I think you can. By George, I think you can. Come on, work, buddy. What are you doing? Thank you. Look at that. Now, as we see here, we edited this file to create a reverse shell over to our system here, and it's ran as root because this is ran as root. All right, so now that we have that one, let us try out shared object injection. Let's go ahead and exit this out. Clear our screen. All right, so with this example, we're going to be looking at an SUID executable that is vulnerable to this shared object injection. So let's take a peek at it here. We got user local bin SUID SO. Okay. So what is it doing? Progress bar, and that's it. Okay, so we don't really know what it's doing except that. So let's look into it. Let's by using the program strace. Going to go strace bin SUID SO. Then we're going to have the standard error be redirected to our standard out so we can see the errors that happened. And then we're going to grep extended expressions of open, access, and no such file. Okay. And as we see down here, trying to load a config file that cannot be found because it's not there. Now, what do? Let's make our own. So we're going to just simply go make dir and put this in the home/user folder. Config. Okay. Now we're going to take in the example shared object here, compile it with GCC, and then use this as a library that this should be calling. Okay, now that we set that, simply execute this here by going to user local bin. I said local, thank you, bin suid.so. Now we should get a root shell. All right, let's clear that out. Next up, SSH keys. I want to do this one. This one's fun. So in order to find this folder, we're going to use the ls and -la to list everything, including hidden. And let's see, let's go back a step. Actually, do that for the entire root path. Why did I put cd? The root path is going to be the slash right here. So as we see, ls.la just only listed everything that's in our current directory. If we add the slash, we get the root directory as well. And we see right here, .ssh. So let's go ahead and cd into that. And we have a root key. So what do? Let's go ahead and cat what this is. Copy all of this here. Okay. Okay, this is simply called root keys, so we're just going to do that. Paste this here. Save it like that. I'm going to use chmod to give actually 600 permissions to this. Then we're going to use SSH identity, and we're going to use a -i switch for the identity file, which is the file that we're using to connect here. We're going to try to connect as root to the IP address of this target here. And as we see here, we have an official root shell. So we did not need no password. We didn't need a password for this because this was being connected. This was getting all of its verification from here, which is the root key. All right, and let's do one more. Let's do NFS. Alrighty, clear that out. Let's go back to home user on this one. Alright, and exit this, clear this out, fantabuloso. Alright, now let's check out the current NFS share configuration. And we're going to go cat etc exports. And we see temp folder, and no root squashing. Okay. Excuse me. So, what we're going to do on our system here is we are going to create a mount point on here. Alright, so let's go ahead and make our directory. Okay. Oh, what in the cribbity crap? Okay, dang it. Alright. Okay, there, let's try this down. Hang on. Why am I self-raising now? Let me just do it from here. Okay. Huh. Dang, bro. All my stuff is doing this. Let's try something different. Whoops. Dang. The hell's wrong with this temp folder? Okay. Looks like I ain't using it. Alright, so alright, so I'm just gonna make a different one then. Alright, so let me do this then. Okay. Mount O read write with our version. Whoops. Goes to and our IP address. One second. There we go. Sorry, I'm all over the place here. All right, copy this. All right. Okay. Fingers crossed. Crap, Mount Point does not exist. Oh, dang it. That stinks. To high hooven. Alright, let's try this. Okay, let's do it like this instead. Alright, let's make up some stuff on the fly. Alright, TMP, TMP1. NFS version not supported. Okay. All right. Well, well, NFS, you stink on ice. All right. Let's try something different here. All right. Let's go back a step. I'm gonna give you one more. Dang it. I'm gonna make this right. All right. So let's go over to here. Let's connect again. Let's just use the config files instead. All right, so let us peek at what is in the home user folder. So we have my OpenVPN file here. So let's go ahead and see what's in it. And going down the list here, looks like that we have some credentials here. All right, so now we're able to get this information from his config or from his OpenVPN file. So let's see what this is. Go and cat that results there. Root. Okay, give us some credentials. Root password 123. Cool. So those are some examples there of doing actual like privilege escalation. Sorry, that last one was stinking to high heaven like sad sacks, dirty drawers. Sorry for that reference there, but I had a blast doing this one. It did take a minute. There's a lot to unpack, I know. I'm glad you guys were able to take this time with me to go ahead and share it while I go ahead and walk through it. Don't forget to like, share, subscribe to be updated on future content. I am Ch1-R0n1n, and I am out.